When ice became the foundation, nothing here was meant to last. The ground cracked with cold, the air burned the lungs, and beneath it all lay ice older than memory, shifting, melting, refreezing in slow, unstoppable cycles. Yet in this frozen expanse, someone chose to build a hotel, not on rock, not on soil, but on ice itself. At first, the idea bordered on absurd. Ice moves, ice fractures, ice disappears. Every rule of construction warned against it, and yet this hotel will become one of the most radical experiments ever attempted in extreme architecture, proving that even the most unstable foundations could hold, if understood deeply enough. To understand why this place matters today, we must return to the first expedition. The site lay deep within a polar region, where permafrost dominated the landscape. Beneath a thin crust of snow rested layers of ancient ice, compressed by centuries of weight and cold. It looked solid, it felt permanent, but instruments told a different story. The ice was alive, flowing millimeter by millimeter each year. Traditional foundations failed immediately. Test pilings cracked as temperature gradients shifted. Anchors loosened as the ice crept. Even lightweight structures warped as the frozen ground subtly rearranged itself. The land was not hostile, but it refused to be pinned down. The breakthrough came when engineers stopped thinking of ice as a surface and began treating it as a medium. Instead of resisting its movement, they studied how glaciers distribute load naturally, how pressure spreads across wide areas, how ice yields slowly instead of snapping violently. From that insight, a radical concept emerged. The hotel would not be anchored into the ice. It would float on it. Wide, insulated foundation plates were designed to spread weight evenly, preventing localized melting. Thermal barriers redirected heat away from the ice below. The structure would move with the frozen ground, drifting so slowly it would feel motionless to those inside. But floating on ice introduced a new fear. What happens when the ice shifts unevenly? When one section melts faster than another? When seasonal changes accelerate beyond prediction? As construction began, temperature swings intensified. Storms rolled in harder than expected. Sensors recorded melt rates that challenged even the most conservative models. The ice was changing faster than the data suggested it should. The hotel was no longer an experiment on ice. It was an experiment in time. And as the frozen foundation continued its silent motion, the team faced a question that cut deeper than engineering. Could anything truly be permanent in a place defined by constant thaw? As the seasons turned, the illusion of stillness vanished completely. The ice beneath the site behaved less like ground and more like a slow river, its movement invisible to the eye but undeniable in the data. Sensors buried deep below the foundation plates recorded subtle shifts every hour. Millimeters became centimeters. Patterns emerged, then broke apart again. The first real conflict surfaced when uneven melting began to tilt parts of the structure. Not dramatically, just enough to disturb alignment. Doors drifted from their frames. Windows no longer sat perfectly level. Inside, the changes were barely noticeable, but to the engineers, they were alarms sounding quietly. The ice was not melting evenly. Sun exposure varied across the site. Wind carved drifts that insulated some areas while stripping protection from others. Even the hotel itself cast shadows that altered thermal behavior beneath its foundation. The structure was shaping the ice as much as the ice was shaping it. Attempts to correct the imbalance created new problems. Adding insulation slowed melting in one zone, while accelerating it elsewhere. Adjusting foundation plates redistributed pressure, but introduced torsion. Every solution solved yesterday's issue and created tomorrow's risk. Tension mounted as projections grew more uncertain. Climate patterns were shifting. Seasonal melt periods extended longer each year. Data from past decades no longer applied cleanly to the present. The ice was changing faster than the models had promised. Some team members argued the project should be temporary by design, a hotel meant to exist only for a limited time before being dismantled. Others believed adaptability could still win. They insisted the structure could learn, recalibrate, survive. The breakthrough came from a glaciologist who reframed the problem entirely. Ice, she explained, doesn't fail because it moves. It fails because movement becomes uneven. Glaciers remain stable when their flow is balanced across their mass. Instability arises only when pressure concentrates. The solution was counterintuitive. Instead of fighting uneven melt, the hotel would encourage uniform change. Heating systems were re-engineered to release minimal, evenly distributed warmth downward, smoothing temperature gradients beneath the entire footprint. Adjustable foundation plates were synchronized, allowing sections to rise or settle together instead of independently. The structure would no longer react to the ice's movement. It would guide it. But implementing this idea meant surrendering control over precision. The building would be level only in relation to itself, not at any fixed external reference. It would drift, tilt, and adjust slowly, deliberately, constantly. The hotel was no longer anchored to the landscape. It was becoming part of the glacier's journey. As systems recalibrated and the structure settled into its new equilibrium, one question grew heavier than all the rest. What would happen when the ice itself reached a tipping point no amount of adaptation could smooth away? The idea of guiding the ice rather than resisting it pushed the project into its most uncertain phase. Once the systems were synchronized, the hotel no longer behaved like a fixed structure. It behaved like a slow-moving organism, adjusting itself in response to forces far beneath human timescales. At first, the changes were reassuring. Foundation plates settled together. Stress readings flattened. Internal alignment stabilized. The ice, relieved of uneven pressure, flowed more smoothly beneath the structure. It felt as if a fragile truce had been reached. But peace on ice is never permanent. As summer advanced, melt rates accelerated beyond historical records. Pools of water formed beneath the surface, migrating unpredictably through cracks and channels no one could map. The glacier's internal plumbing awakened, redistributing mass in ways that challenged every assumption the team had made. The hotel responded as designed, rising and settling as one. But the scale of change grew harder to ignore. Exterior walkways shifted by centimeters over weeks. Panoramic windows framed slightly different horizons each morning. The landscape itself appeared to drift. Guests had not yet arrived, but the emotional weight pressed heavily on the team. They were watching the future of the project unfold in real time, and that future was unstable. Debate returned with force. Some argued the hotel had become too dependent on predictability in an increasingly unpredictable climate. Others believed the adaptive system was proof that coexistence was still possible, even as conditions changed. The disagreement was not technical. It was philosophical. Were they building resilience or postponing the inevitable? The tension reached a peak when a sudden temperature spike triggered rapid surface melt across one quadrant of the site. Sensors recorded accelerated downward flow, faster than the synchronized systems could smooth. For the first time, the hotel's internal equilibrium wavered. Alarms activated. Engineers rushed to stabilize distribution, redirecting thermal output, recalibrating plates in near real time. The structure tilted slightly, not dangerously, but noticeably. It was a warning. The ice was approaching a threshold. In response, the team faced their most difficult decision yet. They could lock the system into maximum correction mode, forcing artificial balance at the cost of increased thermal stress. Or they could allow the ice to move more freely, accepting greater drift in exchange for reduced internal strain. Control versus surrender. After hours of debate, they chose the latter. The correction systems were loosened. The building was allowed to follow the glacier's flow more honestly, absorbing change instead of smoothing it away. Precision gave way to patience, and something remarkable happened. The ice stabilized. By removing resistance, pressure equalized naturally. Meltwater redistributed without concentrating force. The glacier returned to its slow, ancient rhythm. The hotel drifted gently with it, no longer fighting the direction of time. The emotional impact was profound. The team realized they were not preserving stillness. They were learning how to exist inside change. But one final moment remained. The true test would come not from gradual melt, but from sudden cold, when the ice would refreeze, contract, and remember every movement it had made. Only then would they learn whether a foundation of ice could truly hold. The freeze arrived without drama, as polar nights often do. Temperatures dropped steadily. Meltwater vanished into hardening ice. The glacier slowed, then tightened, contracting around every channel it carved during the summer. This was the moment the team feared most, when movement would reverse, when the ice would remember every shift and test whether the hotel could survive being held in place again. Sensors recorded the change hour by hour. Pressure increased evenly across the foundation plates. The synchronized system adjusted gently, allowing contraction without concentrating stress. There were no sudden shocks, no cracking sounds, no sharp alarms. The hotel settled into the freeze as calmly as it had flowed through the thaw. When dawn finally returned after weeks of darkness, the structure stood intact, slightly repositioned, subtly realigned, but whole. The true climax came weeks later, when the first guests arrived. They noticed something unusual immediately. The hotel did not feel fixed. It felt present. Views shifted subtly from day to day. The horizon seemed to glide. Yet inside, everything felt balanced, restful, secure. Guests described the sensation as floating through time rather than standing still in space. What had once terrified the designers became the hotel's defining signature. The ice was no longer an enemy or a risk to be hidden from. It was part of the experience. Guests learned to read the landscape through the building's gentle adjustments. They understood the glacier not as a backdrop, but as a living foundation. And that is why this hotel matters now more than ever. In a world where change accelerates beyond prediction, it stands as proof that permanence is not about resisting time. It is about moving honestly with it, about designing systems that adapt without denial, that accept transformation without fear. The hotel built on ice did not outlast a glacier. It joined its journey. And in doing so, it taught us a quiet lesson, that stability can exist even when nothing beneath us ever truly stays the same. Subscribe to join the journey. When ice